design process. So it's not about engineering design, rather the process of engineering design. So আমরা প্রথমে will try to define each of these terms. এখানে তিনটে শব্দ আছে, engineering, design, process. So we will try to separately define these words and then we'll understand what it means, right, by engineering design process. So the word engineering, it came from the word engine. Right? So early 17th century, the engines, the machines that were used in the wars, right, were called engine. And the people who are working in those machines for maintenance operation, so they were called engineers, right? Then fast forward to 18th century, then the steam engine was invented by James Watt, and that brought a revolution that made these engines very efficient. And those engines brought in industrial revolution, the first industrial revolution. And then those engines found applications for building roads, bridges, highways. And then because of this widespread application, the academic program that's called civil engineering that started. So that is the beginning of engineering discipline. The formal study of engineering and discipline. So first one was civil engineering that started with the application of the steam engines for the construction of roads, bridges, and highways. And slowly, the advancement of technology, the other engineering discipline also evolved, like electrical engineering, then mechanical, and then we have the latest came the computer engineering in 1970s. And now we have so many other engineering disciplines, like transportation engineering, right? Or environmental engineering, water engineering. So there are many other non-traditional engineering disciplines. So engineering, this word has two meanings. One is the verb meaning, the other is the noun meaning. Though we are more familiar with the noun meaning, that like it is a field of study that I just discussed, and it is also a profession. Engineering is a profession. So these are the noun meaning, and what is the verb meaning? That is more relevant for us in today's discussion. So the verb meaning is to solve a real life problem. Solve a real life problem using the knowledge of science and math through the development of new technology or using existing technology in an innovative way. So in this context, we can also mention that not only the engineers, the doctors, lawyers, the economists, they also solve real life problem, right? But what's the difference with the engineers? Like economists, they also solve real life problem, right? But they do not use the knowledge of science. They use the knowledge of math, of course, and they do not use any technology. So this is the difference between you know the economists and the engineers. The lawyers, they also deal with real life problem, but they don't use any science and math or technology. Doctors, they're also dealing with real life problem, but they are using technology, right? But the difference with the engineers, that engineers, they develop the technology, they develop new technologies to solve real life problem, or they use the existing technology in an innovative way. So what is technology? Technology is a process, tools, or uh, any new system developed to solve a real life problem, that is known as the technology. And to develop the technology, you need to use the knowledge of science and math, right? So there's a close relation between the science, math, technology, and the engineer. And that's how the word STEM came, right? Science, technology, engineering, and math. Science is the study of nature, finding the inner working principle of nature, right? And technology, process, tools, techniques developed to serve humanity. And engineering, application of science to solve real life problem through development of a new technology. So you see the relation between science, technology, engineering, and math, and where does we stand as engineers. So the full definition of engineering, so application of science and math to develop a technology and which will be used to solve a real life problem, right? So this whole thing is engineering. Any question, guys? So to be engineer, you need to have a strong foundation of science and math, right? So this is the difference between engineers and technologists or technicians. Technologists, they just use machine, they don't develop the machines, but engineers, they have to develop the machines. So they need a strong understanding of science and math to develop the technology. Mm. So now we have defined engineering. So now what is design? Design is the solution, right? The engineering is solving a real life problem, and design means from the engineering perspective is actually the solution of that problem, right? It is not any solution. Like design, we know any decorative pattern, we can call it a design, right? So any art, drawing, right? So when the artist draw, right, paint something, right? So there is no conditions attached to it. There are no requirements or constraints, restrictions for his drawing. But for engineers, the design, it has to meet some requirements and specifications, and that has to be done within some constraints, right? So engineering cannot just design anything. It has to meet some specific requirements and specifications. So like this, any drawing, it can be a drawing, right? A blueprint of a building or it can be a product itself, like a car, or it can be a prototype, right? Any of these things can be called a design, right? That meets certain requirements and specifications under some constraints. Two big important, constraints are time and money, right? So engineers, they will always have some limited amount of money to, you know, design their product. And time is also limited. They have to, you know, produce or build the product uh, within some time frame. So it can be 1 year or 2 years or 5 year, whatever. So that is fixed, and they have, this is a constraint. And money is also fixed. It can be $1 trillion project, but still $1 trillion is a, I mean, finite amount of money, right? So these are two constraints, and there can be other constraints from government regulatory bodies, and there can be constraints from engineering perspective, right? So technical constraints. So there can be many different constraints, right, under which the engineer has to work and produce the solution. Now, the solution can be reached in multiple ways, right? You see, if we consider just the transport system, from if you want to travel from one point to another point, so you see there are so many different options to travel. Let's say we can travel by road, or we can travel by air, can travel by sea. Let's just say just one mode of transportation, that's travel by road. And even then, there are so many different options, right? There are buses, there are cars, there are maybe motorcycle, and there are so many other transport systems, right? So there's so many solutions are there, right, for one to solve one problem. So there are multiple ways. Even just if we consider one mode of one type of transport system like car, so there are so many designs, right? So many different companies, and each of the companies coming up with multiple design options, right? So a solution can be reached in multiple different ways. So engineers, when they try to solve a problems, they have to come up with multiple solutions and find out which one will be the optimum, right, for the application at hand. So they have to come up with multiple design solutions, and from that they have to choose the optimal solution, right? And whole this thing is called engineering design process. Do you have a problem at hand, right? So you develop a solution to meet some requirements and specifications under some constraints. You come up with multiple designs, right? Be creative, and you choose the optimal solution applying your engineering judgment, right? So the your judgment has to be a professional judgment that can justify it, right? That can be justified. You cannot decide based on intuition, right, or common sense. To apply engineering judgment, right? So this whole thing is engineering, we call engineering design process, right? And in this final year design project, whatever problem you come up with, right? So from identifying the problem and then finding the solution. You have to follow this, basic, uh, I mean, process, right, to complete your design project. Any question, guys? Okay, so we discussed about engineering design process. So as an engineer, so the qualities that one should have, one I have already mentioned, the strong foundation of in science and math, and they also have to have this quality of being creative, right? So the more creative you are, the more successful you will be in your engineering profession, right? Unlike the doctors, right? They don't, or the lawyers, they don't have to be that creative, right? But engineering, it is one of the fundamental, right? And their quality to be creative, right? To be successful in their career. Now, we try to define the process, right? Or if you understand what a process, what it means, right, then it will be easier to understand what engineering design process, right, signifies. Process will have three components. One is input, the output, and the process itself, right? Let's take an example of the fan, right? The electric fans. So for this simple, electrical appliance, the electric energy, that is the input, right? That rotates the motor. And then we get the flow of air. So that is the output, air flow. And the fan itself is the process that is processing the input energy and converting into mechanical energy and producing the flow of air. So any process will have these three components. There will be input, and there will be a process that will, process this input and produce the final output. Now, the process, we can improve the process by adding some control, right? Like the fans, will come with a regulator, right? So you can control the speed of the fan, the flow of air. So with the simple movement of the rotation of the regulator. So you can control the flow of air. Okay, so this is how you improve the process, by adding a control mechanism. Then process can be further improved by adding a feedback system, right? So let's say we want to automate the process. The whenever temperature rises, the speed of the fan will increase. So there will be a system that will measure the temperature, that is the air that is coming out, or the temperature of the room, and then it will provide feedback to the control system. And depending on the feedback received by the control system, it will adjust the speed of the fan, right? So now the process is automated, and you don't need to rotate manually, right? It will do automatically, right? It will sense the temperature, and accordingly it will adjust the speed. So now the process has become intelligent, right? This is an intelligent system, right? So now we have, initially there was three: input, output, and process. Now we have added two more. One is the control and the feedback. So in total, we have five components in this process. And with that, we have an intelligent system. So similarly, for engineering design, right, there we have five components. One is the input and the output, the process, control, and feedback. What will be the input in this case? Hello, guys. Are you listening?
Yes, sir.
So what will be the input? Input is the problem, right? Problem that we want to solve. So that is the input, right? And then output. Output is the solution, right? Can be a prototype, design, product, right? So these are the outputs, right? So once you have designed a product, right? So then you take the feedback from the clients, from the customers, right? So according to their feedback, right, then you improve your product, right, through this control mechanism. So from the feedback, what is the control in the engineering design process? Now, control is the requirements and specifications, right, following which you make your product, right? So upon receiving the feedback from the clients, right, you make changes in the requirements and specifications so that better serve the needs of the customers, right? And then you redesign the product, right? So that is how the whole engineering design process will work, right? With these five components. Now, steps in engineering design process. So these are the major steps. There can be other steps, but these are the major steps one has to follow. So it starts with defining the problem, right? What problem you have to solve, right? So that has to be stated in a statement, right? In in a clear and unambiguous language. So you define the problem very specifically in a clear language. Then you identify the design requirements, specifications, and constraints, the solution that you have to produce, what requirements and specifications it has to satisfy, right? And what are the constraints you have under which you have to produce this solution. So those things you need to identify. So that is the second step. And then third step, you produce solution, multiple design solution by this and get the elementary design of your solution. Then you have a number of solutions and then you choose the optimal one. And when you choose the solution, you check with the requirements and specifications how well they fulfill, right, the how well they meet the requirements and specifications that you have initially, identified. So next step is planning. You identify who are the people you will need to, you know, to design this the product or solution. What are the tasks that need to be done? What are the materials that are needed? What are the task durations? How long it will take, right, for the different components of the tasks, right? And how much budget you will need to implement this design problem. So that is the planning stage. So once the planning is done, then you go for detailed design. So in the detailed design, there can be three steps. One is the modeling. So this is the theoretical part. You develop a theoretical model, a mathematical model of your problem. And then you can do the simulation, computer simulation. There are many simulation tools available nowadays. So you can use simulation tools to simulate your design and see how it works and how well it matches with your theoretical model. So once you have validated your design through modeling and simulation, then you go for building the prototype that meets the requirements and specifications. So in this stage, you may also need to revisit your requirements and specifications and see if you need to make some changes in requirements and specifications to build a, better prototype. So once the prototype is built, then you test the prototype and see if there are problems. You debug and redesign your prototype. So that is the detailed design part. So once that is done, then you go for manufacturing, and then you go for marketing, and then once it's marketed, you go for collecting the feedback from the customers, and again revisit the requirements and specifications. See if you need to make some changes in requirements and specifications to better serve the customers. So this goes in a loop. So the requirements and specifications throughout the process, it's not a one-time job. We keep on, revisiting the requirements and specifications and modifying them to come up with a better design, more practical design. So these are the major steps in the in design process. For your final year design process, final year design project, you have, you don't have to do the last three. Your, I mean, job ends with the detailed design and building the prototype, testing the prototype, and that's it. Testing and debug and redesign. So here your main project ends. You don't go for manufacturing or marketing. So these are for, the companies who are in business, right? So now we discuss in some detail few of the design steps. One is the defining problem statement. The other is the what are the requirements and specifications? How do we identify? And then the multiple solutions. How do we choose optimal solution from multiple design solutions? So defining problem statement is the first step in engineering design process. So before you can find a solution, you have to clearly state what is the problem, right? In a clear and unambiguous language. It has to be concise and precise, clearly identifying the problem. So if you are not very clear in identifying the problem, so you will not very accurate in finding the solution. Solution will be also vague. If you don't have clear picture of the problem. So you have to first define the problem in a very clear and unambiguous language and concise, precise, to the point, right? So usually the problem statement should not be more than one page, or it should be less than one page. And the problem statement should have three components. One is the background of the problem. What is the background? And if there exists any solution, and then propose a solution. So these are the three main points that you should cover in your problem statement. So first, lay out the context background of the problem from the perspective of the user. So in the background, you talk about what is the origin of the problem, and then pinpoint the problem, and then reason why the problem is worth solving, right? So you will be investing time and energy and money, right, to solve the problem. So it has to be a problem that is worth solving. So there can be, I mean, so many problems, but people probably don't care about certain problems, right? I mean, they can live with those problems, and it doesn't affect them much. So if that is the case, I mean, it's not worth solving. It's not worth spending that much of time and energy and money. So it has to be a problem that is worth solving, that people are looking for solution, that people will spend money to buy the solution. So that is in the first, background, in the first part of your problem statement, that you have to explain the origin of the problem and what's the exact problem and why it is worth solving. So now in the second part, you focus on if there is any effort to solve the problem in the past. So if there exists any solution, so what are the pros and cons of the existing solution? What are the limitations of the solution? Why people are not happy with the solution, right? So you do some literature search, right? And you can conduct some survey of the people, right? What are the problems they are facing? Why they are not happy with the solution? And then you propose a solution, and the solution should be a viable and feasible one. And that finding the solution will also require some research, right? What are the solution people have, come up with under similar conditions elsewhere, right? So you can do some literature search, you can browse the internet, collect some technical reports, right? So you can try to find some information regarding the problem, similar problem and solution that were, developed under, for similar problems elsewhere. And the solution you provide, that should be viable and a feasible one. So viable means that there will be demand for this solution. So you propose a solution but that solution will, cost $1 million for the people. So nobody will buy that solution because it is so expensive, right? So it is not viable. That has to be within the purchasing limit of the people, right? So then it is viable. Feasible, that idea can be easily implemented. So it is a feasible solution. You propose a solution that will require some material that is locally not available. Maybe you have to import it from far away country, let's say South Africa, right? So again, that is not feasible. It will, you know, increase the cost of the solution, and it may not be always possible to import the material, maybe for different reasons. So again, this will not be a feasible solution. So when proposing this solution, you propose a viable and feasible solution. So these are the main 3 points of your problem statement. You define the problem and state the um, starting with the background. What is the background of the problem? And see if the problem is is worth solving, and try to see if there are any past effort to solve the problem. If there exists a solution, what are the pros and cons of the solution? And then you propose your solution. So the more accurately you can define your problem, the more accurately you can design the solution of the problem. So these two are directly linked, right? So you have to, though the problem statement is a short write-up, less than 1 page, but it requires a lot of effort, a lot of background research, survey of local population. So this will require some time, energy, and effort from your part to write the problem statement correctly, precisely, and to the point. So here is an example of a problem statement. So this is actually a problem statement for a master's work, and the problem statement is separated in 2 para, right? So in the first para, it's written the Dublar Chor is an island in Bangladesh with an area of 66.5 kilometers square, located in the Bagerhat district of the Khulna division, with a small amount of population. So this is part of the background, what we mentioned, right? How to write problem statement. Should we start with the defining the problem, and in that you write something about the background of the problem, give a background. Due to the island's location, establishing grid integration of electricity for population of the island will not be possible even in future from the perspective of both fuel cost and electricity production. So because of location of the island, it is in a remote location. So the grid connection is not practical, right? So what the people are doing, why at present the region is dependent on the diesel generators for fulfilling electricity demand. So the problem is the island is remotely located and grid connection is not feasible. So there is a problem of having electricity. So what is the present solution? There people are using diesel generators, right? So that is the solution, existing solution. right? So he have stated the problem and he stated the existing solution. Now, in the second para, he is proposing a solution apart from what exists. Solar and wind-based renewable energy sources are clean, feasible, and moderate by cost. A hybrid macrogrid system would be a great solution for this region. Contextual analysis on the past hybrid power system activities, constraints of the current innovation, and case studies on different applications are discussed by Nair and Kim. So he is mentioning some solution, right, that has been discussed in the literature for similar situation. And then another reference is mentioning theory-based structure framework of microgrids proposed by H. Wang in regard to minimize overall cost. So he has mentioned two, research work by two different authors about a solution under similar situation. The objective of this study is to design and analyze an affordable hybrid microgrid system based on solar and wind energy for the community of Duplar. So now in the last sentence, he is proposing his solution, right, after mentioning the two cases, right, of solution under similar situation in the literature. He is proposing his solution for the Duplar, right, an affordable hybrid microgrid system based on solar and wind energy. Now, it seems that this is quite accurately captures almost all the components of the problem statement that we have discussed in our previous slide, right? So first he gives the background of the problem, then he mentions what is the existing solution people are using. The present region is dependent on diesel generators for fulfilling electricity demand, right? So then he is proposing his solution after mentioning some similar works done elsewhere, right, for similar problems. So now you see that there is one thing still missing here. So he has mentioned the existing solution of the problem. The people are using diesel generators, so that's the existing solution. And then he went to propose his solution, which will be viable and feasible. But he doesn't mention what is the problem of the existing solution. He has mentioned the solution that people are using diesel generators. So then he went to propose his solution, but he didn't mention what is the problem of the existing solution. The existing solution maybe is creating a lot of pollution, right? Because diesel will generate a lot of pollution, right? The existing solution will be probably expensive, right? Diesel generators are expensive, diesels are expensive, and people in the remote island, they are poor farmers, right, or fishermen. They cannot afford diesel generators. Only few, rich people who are doing business, right, probably they can afford. Most of the people, they cannot afford this solution. So these are the problems of the existing solution that should have been mentioned in the problem statement. Then he should propose his solution. So we propose solar and wind-based renewable energy that is environment friendly, that is clean, right, renewable, and that will be also affordable. Any question, guys?
Sir,
Yes. So this is how you write your problem statement. This is the very first thing, right? You have to do it, and for that, a lot of uh, effort, time you have to spend, right, to come up with, you know, a properly written problem statement. So once you have, you know, you have articulated your problem statement, then you define the, I mean, you have already proposed this solution. So now you identify what are the requirements and specifications for your solution that you have proposed. Requirements and specifications, they refer to the same thing, but from two different perspectives, right? Requirements are from the perspective of the user, and specifications are from the perspective the of the engineers. So, like, let's say you need to design an amplifier, right? So the amplifier has to, supply power to some load, right? So how much power the amplifier has to supply to the load, so that will be a requirement, right? And what will be the input signal, so that will be also mentioned by the client, right? What will be the level of input signal? So depending on the input signal and the power supply to the load, so now the engineer has to design the amplifier. So this amplifier has to supply this much power to the load, right? So then what will be he has to find out what will be the gain of the amplifier. So what will be the level of the output voltage and current of the amplifier, right? And those will be the specifications, right, of the amplifier. So specifications again can be, it will be at the system level. At the system level, when you consider the whole amplifier as a system. So as at the system level, there's this requirement is the input voltage this much, output voltage this much, output current this much, gain this much. So these are the requirements, sorry, specifications at the system level. Then you have to design the amplifier, find out the resistance values, the current and voltage that the transistor has to handle, right? The capacitor values. So then those will be the specifications at the component level, right? So like this, so engineers has to generate, right, a list of, I mean, the specifications, right, for the system and for the whole set of components that will be used to construct the amplifier, right? So user requirements should be clearly clarified and clearly documented to generate the corresponding specifications. So the first to you need to understand what are the requirements, right? Like amplifier, it has to supply this much of, deliver this much of load, this much of power to the load. Then there can be range of frequencies, right? What will be the range of frequencies of the input signal? So that will be another requirement. So this range of frequencies that amplifier has to amplify, so that will determine what will be the bandwidth of the amplifier, right? So that will be another specification. So Unless you know clearly all the requirements, you will not be able to generate the corresponding specifications. And if you cannot generate the necessary specifications, you will not be able to correctly, accurately design the amplifier, and that will lead to the failure of your product. So it is important to identify all the requirements and accordingly, generate the necessary specifications, right, that will meet those requirements. So the engineers must find out what are the needs of the user, customers. Sometimes customer may not be very specific about the requirements because he doesn't is not a technical person. So he may not have the clear understanding about the requirements. Then engineer has to sit with the customer, client, right, have a discussion and try to find out exactly what are the requirements, right, of the engineers. And so he has to find out the exact numbers, right, for different requirements of the system. Also, will be the requirements from other stakeholders like government regulatory bodies, especially if you are building bridges, highways, or buildings, right? So there will be government regulations about those, right? How to build, and what not to do, right? What must be, what conditions must be satisfied. So those are legal issues, right? So those will, I mean, the additional requirements. Then professional bodies, there will be standards and codes you need to follow, right? And there can be other groups who are directly or indirectly affected by the project, right? When you're building, the roads or highways, the bridges, the local people are affected, right? So you have to consult with them, what are their requirements, try to find out and how to satisfy all their requirements, right? So they are not adversely affected by the project, right? So establishing correct design requirements is the first step in the engineering design. So it has to be accurate and complete, so you can generate the complete set of specifications. Requirements can be classified into different types, different categories. First, we start with performance requirements, functional, then non-functional, ergonomic factors. Functional, what function it has to perform, like amplifier, it has to amplify, right? So that's the functional requirement, right? Non-functional requirement, like the size of the device, right? The durability of the device, right? So those are non-functional requirements. How it will look, right? Non-functional requirements, right? The human factor, so the people will be using, so it has to be, I mean, comfortable for them to use, right? Is aesthetics, appearance. There are manufacturing requirements. When you go for manufacturing, what are the materials, process, assembly, quantity? So huge set of requirements will be there for manufacturing the product. There are operational requirements, right? So when you operate the system or device like a car, right, or an electrical appliance, right, how do you operate and what are the requirements that must be satisfied? What are the safety requirements that must be installed in your product so it is safe to operate, right? Disposability requirements, once the lifetime is over, so how the material should be disposed, right? What are the disposability requirements? So there can be a huge set of requirements for a simple, just one single product, right? So once, and also to establish correct design requirements, it is important to establish attributes, constraints, preferences, and expectations of the user. Two different user, let's say, they can have same functional requirements, but they can have completely different attributes. So let's say X and Y. Hello, is everything okay? Please mute your mic so that we don't get noises. We're getting noises. So can you please mute your mic? Like two different customers, like let's say X and Y. Let's say two different customers, X and Y. They need to travel from their home to office, right? So they need a transport for traveling. Now, X is a has a simple job, right, with modest salary, and Y is a big boss in some company and draws huge salary, right? So they both need transport to travel. So since X he cannot afford that much, right, to buy some luxurious car, so he goes for a simple Toyota car, right? And why? Since he is in a very highly prestigious job, so he goes for a, let's say, Mercedes Benz, right? So that meets with his, that goes with his status and his position, right? So, and X buys what he can afford. So they have the same, the performance, the functional requirement is same here, but they have different attributes, right? So they are choosing two different products, right, to meet their requirements. So this way also you consider the client's preferences, their expectations, right, while you note down the requirements, right, that need to be fulfilled. So final words about the requirements and specifications. It is not possible to enlist all factors in design requirements and specification, but try to be as comprehensive as possible, right? So as I mentioned, there can be so many requirements for just a single. There can be functional, non-functional. There can be manufacturing requirements, safety requirements, right? Disposability requirements, operational requirements, right? So many of them. So, and it's not possible to be list all of them, but try to be as comprehensive as possible. So it is the first step in any engineering design. So if you are not very correct in defining requirements, don't expect your product will not have any defects. So try to be as accurate as possible. And it is not a one-time job, it is iterative, repetitive, and continuous process. So it is not just that one time you have defined and that's it. I mean, you can stick to that for the whole, during the whole product development process. So you have to modify and update from time to time. It's not and it has to be documented, right? And it is not a simple document. It has a very strong legal value. The requirements and specifications, it has a legal value, right? It has to be documented. It is a promissory note we give to our clients. It establishes the relation between you and client. If you don't deliver what is written in the specification, your client can pull you to the court and seek damages, right? Whenever we purchase our equipment, lab equipment, it comes with the manual, right? And manual gives all the requirements and specifications in many pages, right? And if you find it, it is not according to the requirements and specification, so then we can sue them, right? We can sue the company, so sue the engineers, right? So when you write the requirements and specification, you have to be very careful that you make the product that satisfies all the requirements and specifications. It works according to the requirements and specifications. Otherwise, the client can sue you and take you to court and seek damages. So we have to be very careful in writing, right? This is scientific language, it's legal and scientific language. Now, how to identify the optimal solution? So you have to come up with multiple design solutions, and then from that you have to identify the optimum solution. And the optimum solution, that the process of choosing the optimum solution has to be through applying some judgment, professional judgment, your engineering judgment, applying engineering and scientific knowledge, because the decision has to be defendable, right? So that you can defend when it's necessary. Let's say engineers, they build a bridge, and if the bridge collapses, right, then engineer will have to defend, right, his decision why he has built the bridge in a certain way, right? What are the materials he used, right? What are the designs, right? Different design parameters. So all these things he will need to defend in the court. And if he cannot defend, then his license will be revoked, right? And his professional life career will be finished, right? Probably he may also end up in jail, right? So there are serious consequences. So whatever decision you make, that has to be defendable, justifiable. So how now we discuss uh, how to choose the optimal solution from multiple design solutions, right? So one of the ways to do that is to identify the criteria based on which we will choose the optimal solution. So first, find out what are the criteria, right, that will be used, right, to identify the optimum solution. So identify the constraints first, identify the criteria and then constraints. Then some criteria are more important than the others, right? There can be a number of criteria, but not all the criteria has the same importance, right? Some criteria will be more important than the other criteria. So rank them according to their importance, right? Or you can add some weightage to each of the criteria, right? So assign a weight to the different criteria and rank them according to their weight. So here is an example of choosing the multiple designs, choosing an optimal solution from multiple here choices. So this is about uh, where should I go on holiday, right? So people, a group of people, let's say they want to go for a holiday, right? And they are considering different locations for their to spend their holiday, different countries. So there are 5 countries mentioned here: Spain, Greece, France, USA, and Australia. So now the question is, where should they go and which will be the best place, right? So in terms of what, right? How do they decide? So they identified 5 criteria to decide the best, destination for them to visit. So the 5 criteria are listed here on the left side of the table, left column, leftmost column: cost, weather, things to do, things to see, and does this please everyone. So these are the 5 criteria, and so the 5 criteria they have identified, and based on these 5 criteria, they will decide which one will be the best option for them. Now, the 5 criteria, they also rank them according to their weight. The cost has been given the most importance, weighting. So this factor 5 is assigned for the cost. Weather is the second most important, it's given weight of 4. Then things to do, weight is of 3. Things to see, weight is 2. And does this please everyone, weight is 1. Now, each of the destination, they have been now given a score, right, for the different criteria. For the Spain, the different criteria, the score is 5, 4, 1, 2, 2. For Greece, this is 4, 5, 5, 5, 4. For France, these are the scores. For USA and for Australia, right? So now each of the destinations, they have been given a score, right, for different criteria. Now different criteria has different weight, right? They have different weights. So now how do we now calculate, right, the total score, the final score for each of the destinations? So we take the sum of the product, right, of the scores. And we have, for let's say for cost, Spain has got a score of 5 and the weight of criteria is 5. So multiply 5 and 5, right? So that will be the final score for the weight, right? And then for weather, the weight is 4 and the score is also 4. Then we multiply 4 and 4. For things to do, weight is 3 and score is 1. So multiply 3 and 1. Things to see, weight is 2 and score is also 2. Multiply 2 and 2. For everyone that pleases, this 1 and score is 2. So multiply 1 and 2. So once you have multiplied the scores with their corresponding weights, right, and then you add them up. So when you add them up, the final score is given here at the top. The Spain total score it got is 50. Greece, the total score it got 69. France got 48, USA got 40, and Australia got 18. So if you compare the score, the Greece scored highest, right? Got the highest score, right? So based on this criteria, right, that has been decided to choose. So Greece scored the highest. So our destination, the final destination will be Greece to spend our holiday, right? So this is how we can, it's one of the ways we can choose the optimum solution from multiple design solution. So you have proposed a solution. Now, so you have multiple solution. You identify what are the criteria that should be, used to, uh, choose the optimum solution. It can be efficiency, it can be cost, it can be safety, durability, right? So these are some of the criteria that you can consider, and there can be so many other criteria. Concluding remarks: unlike scientists, engineers are not free to select the problems that interest them. They must solve problems as they arise, and their solutions must satisfy conflicting requirements. Usually, efficiency costs money, safety adds to complexity, and improved performance increases weight. The engineering solution is the optimum solution. The end result is that taking many factors into account is most desirable. So uh, there are many different criterias, and for our solution is the optimum one. That is, considering our what criteria is the most important for us. Is it efficiency? Is it safety? Is it improved performance? Which one is most important for us, right? So if it is efficiency, so we want most efficient one. We don't, safety can be there, but it's not the main factor. Our main factor is the efficiency. So we want the most efficient system within some cost limit, because money is always limited, right? And safety adds to complexity. So we want a safe system, but within, certain level of complexity, right? Or we want, the most the effective system, right, within certain weight limit. Right? So this is how we can decide our final design. What is the most crucial? Which factor is most crucial for us? And that will be given the most weightage, right, in deciding the final solution. So it may be the most reliable within a given weight limit, the simplest that will satisfy certain safety requirements, or the most efficient for a given cost. Okay, so I am done with today's lecture. If you have any question. No question? আতিফ কি আছো নাকি?
Yes, sir. Sir, I have already taken the attendance. Thank you for conducting the session, sir.
Oh, that's great. Okay.
Thank you, sir. Thank you everyone for joining. So আমরা হয়তো শেষ করতে পারি স্যার।
Okay, then so that will be end of our today's session, and wish you all the best in your final year design project.
Sir, did you take the attendance in the Google Meet, like the people who joined?
Yes.
Oh, thank you, sir.
Sir, I have a question.
Yes, go ahead.
Sir, should we arbitrarily put the weightage to different sources or different elements, money or in our FYDP?
Yeah, that first, it's not arbitrary. You have to rank them according to their importance. Which is the most important factor for you? Is it cost? That you have to decide. No, is it efficiency, or if it is the weight, if it is the safety, and if it is a medical equipment, for example. So safety is the highest priority for medical. It's not the cost, right? If it is some for space application, then probably weight is the most important factor, right? It has to be lightweight. Cost is not the main factor. So if it's for general people use for general, cost probably is as an important factor, right? So that's how you have to determine which one will be the important factor, and then which accordingly you assign weight to different criteria.
Okay, sir. Thank you.
You're most welcome. Shesh. Okay, guys. So that's it from my end, and all the best to your